My name is Emily Ehresman. I am a DO PhD student, and I will be talking about my research on estrogen and repeated sodium deficiencies. So as background, the incidence of hypertension increases after menopause, possibly due to the loss of ovarian hormones like estrogen. A low-salt diet is often the first recommendation, but it's really hard to stick to, so people will often go off and on the diet, essentially yo-yo dieting, and the consequences of this are unknown. So the goal of my research was to determine the effects of estrogen on behavioral changes and hormonal changes after single or repeated sodium deficiencies. In order to do this, I used ovariectomized adult Sprague-Dawley rats and gave them subcutaneous injections twice a week. They received either estrogen or oil throughout the experiment. So after they were ovariectomized, they got a week to recover, after which they were given access to 0.5 molar sodium chloride for 24 hours to adapt. Then they were given 7 days of regular chow, at which point they were started on either oil or estrogen injections. At the end of this period, they got a 2-bottle test where they were given 2 hours of access to 0.5 molar sodium chloride as well as water. Then they were deprived for 10 days through their food. Some animals were never deprived throughout the experiment, and those you will see later are denoted as CON or control. At the end of this period, some rats were immediately sacrificed. Others got a 2-bottle test and were sacrificed, or they were repeated animals that got a 2-bottle test and then continued on to regular chow. Those animals got regular chow for a little more than 2 weeks, and then they were deprived again and got another 2-bottle test. So these are my graphs showing the salt intakes after each sodium deprivation. So I have no differences in single or repeated deprivations or oil or estrogen for salt intake. As for water intake, the estrogen-treated animals drank significantly more water. This meant that they were drinking a less concentrated salt solution overall. Additionally, the repeated deprivation animals drank less water, so they were drinking a more concentrated solution overall. I also measured several hormones using ELISAs. I want to draw attention in particular to the norepinephrine graph up here. So I had significantly less norepinephrine for my estrogen-treated animals, as well as significantly less norepinephrine in animals that were never deprived of sodium. Norepinephrine is a hormone involved in the sympathetic nervous system and helps control blood pressure. I also had significant effects in vasopressin, where estrogen-treated animals again had lower vasopressin. I also had higher vasopressin in repeated deprivation animals and higher vasopressin in animals that were never deprived. So in conclusion, my estrogen treatment did have expected effects on other parameters that I did not show in this particular presentation, but are on my main poster, including body weight, uterine weight, and plasma protein concentrations. I also had persistent behavioral changes in estrogen-treated NAD rats, which consumed less concentrated solution than oil-treated rats. My estrogen-treated rats had lower norepinephrine, vasopressin, and aldosterone, and NAD rats had lower vasopressin and higher norepinephrine. So ultimately, all these changes could be affecting blood pressure, which needs to be explored further.